All right, so 7-2 talks about what's called percent of change. And there are several ways that I could teach percent of change, but I'm going to teach a way that would probably make more sense to you. So if you're walking into a store and you're buying something that has tax, does that increase the price or decrease the price? It increases the price. So wouldn't you figure out the tax and add it back in? Okay. If you're buying some sort of item, whether it's clothing or electronics, whatever it might be, if it's discounted, does that add to the price or reduce the price? Add or reduce? It reduces. So you'd have to figure out the discount amount and then subtract that from your price. So that's how I'm going to approach this for the first section. So let's look at the first section. You can write yourself a note on here, because this is unusual, that you can use a calculator. But show all work. So all the calculator is doing is adding, subtracting, multiplying, and dividing, but you have to show what you're putting into that calculator. So if your work does not look exactly like my work, I will on Monday look at your work and say, I won't take that at all. Because here's what some of you are going to do. You're just going to slap a number on there, or I'm going to see a bunch of switch scratch work that I can't make heads or tails of. And that kind of work won't fly with me. So, example 1. Here's your first step. So if I've got a backpack that's $35 and the tax is 7%, let's talk about converting that 7% to its decimal form. Percents are based upon what number? 100. How many zeros does 100 have? 2. So how many places do you move your decimal point? 2. And we always, when we convert from from percent to decimal, we always move it 2 places to the left. Well, I don't have 2 places to move this decimal point, right? If you don't see the decimal point, it's always to the right of a number. So what do I put here for this place that I ran out of room for? Yep, add 0 as a placeholder. So this is equal to 0.07. So that's what I'm going to multiply 35 by. So I'm going to take $35 and multiply it by 0.07. That's what I'm putting into my calculator. So that's the part that you can do in your calculator, but I have to see how you came up with it. So in my calculator, I'm going to take 35 and multiply it by 0.07. What do I get? 245. Since we're talking about dollars and cents, you're going to round your decimals to 2 places if it's longer than that. This one's not. So I've got $2.45. What does that represent? This is your tax, right? So if I asked you what's the tax on the backpack, your answer would be $2.45. But if I asked you what's the total price, which is what this is asking up here, what do you do with that tax? Yeah. So I need to see the 35 plus the $2.45. I need to physically see this step. And so you can take your calculator and just add 35 to that. Thank you.
Sure.
Thomas, can you come up here? Thomas Clarkin, yeah. $37.45. Well, I would assume that you could do that without using your calculator, right? That's what happens when I get into calculator mode. So this is your final answer, so make sure you put a box around it. That's all that you're going to do. So this whole section, so 2 through 4, you're going to find the tax. That's your step 1, and then step 2, add the tax to the price. You're done. Okay? But then the second part says find the discounted price of each item. So we're going to do number 6. So a discount means I'll walk in the store and the watch is $37.55 and it's on discount for 35%. You have to be aware of what you should be paying for something before you walk up to the register. Have any of you experienced where you walk up to the register to pay for an item that you saved up money for and they ring it up wrong? Did you realize? Well, I happened to be at Albertsons one time. I was buying a single slice of cake. Can't remember why. I think it was somebody's birthday. So I was buying them a single slice of cake. They rang up that single slice of cake as $13.25. I wasn't even paying attention because I was just gonna put my debit card in and, you know, go on. I had a lot of things that was going on. My daughter's next to me and she's pulling on my shirt. Mommy, mommy. I'm like, what? She goes, that's an expensive piece of cake. I mean, this is like my elementary school kid looking at, because she's watching the register, and I'm like, what are you talking about? I said, $13 for a slice of cake. The cashier actually had to call back to the bakery to say, is that, you know, is a slice of cake $13? I said, seriously, do you think Albertson sells one slice of cake for $13? I believe that's the sheet cake price. So she didn't even realize what her cost of one slice of cake should be. So be aware when you walk up there what you should be paying. Target is notorious for having the wrong prices. Notorious. So always know and figure out that discount in your head before you walk up there. So 35%, what's my decimal equivalency? Yeah, here's my decimal point, so move it 2 places to the left, so it's 0.35. So for step 1, finding your discount is exactly the same as finding your tax. You're going to take your $37.55, multiply it by the discount percent, 0.35. Oops, I don't know why I put a 0 in there. Yikes, 0.35, there we go. So put that in your calculator. And what did you get? So I have 13.1425. So go ahead and write all that down, 13.1425. A discount amount is in dollars and cents, right? Cents goes out to 2 decimal places, correct? So I want to round it to the 4. Does the 4 stay a 4 or does it bump up to a 5? Why does it stay a 4? Yeah, there's a 2 next door. If this number next door is 5 or higher, you're going to bump this number up 1. If this number next door is below 5, you're going to leave this number as is. So my discount amount is $13.14. This is my discount. Is that what the question's asking for? No. So then step 2, what are you going to do with that discount? Subtract it, yeah. So take and subtract $13.14. So take your answer that should already be in your calculator. Oh, never mind. Take 37, can't see my work, 37.55 and subtract 13.14. What'd you get? 24.41. So if I were walking in that store and I was trying to estimate my price, would you use the dollar amount of $37.55 for the watch? I wouldn't. What would you round that up to? You could round it up to 38, but you're probably better off rounding it up to like about $40. The closest, easiest thing to multiply by in your head, because you're probably not going to whip out your calculator, although nearly everybody has a calculator on their phone now, don't they? So because most of you have a smartphone and you have a calculator on your phone, you could actually calculate the discount before you get up there by doing exactly what we just did. But let's just say that you don't have that smartphone attached to your body. Would that ever happen? Any of you watch Revolution, the show? Have you ever heard of that? Of course you would be watching it. Well, Revolution is a show where all the electricity goes away. No electricity. So you're like back in the olden days where we have no cell phones, no computers, no television, no, motor cars, nothing like that works either. Nothing operates. So imagine what life would be like without your cell phone. So I would walk in and I would use $40 for my watch, and then 35%, it's in between 30% and 40%, right? Well, what's 10% of $40? Yeah, cut off one of the zeros, right? And wouldn't you have $4? Okay. So 10% of 40 is $4. So what's 20%? What's 20%? 8, right? What's 30%? Add another 4. 12. What's 40%? Add another 4. 16. So I'm somewhere between 12 and 16. What number's between 12 and 16? 12 and 16? How about 14? right? So I would expect to get somewhere around $14 off. What's 40 minus $14? 26. Did I get close to 26 here? It's close enough, right? And I knew that I estimated high, so my actual discount should come out below $26. So if I go up to that counter and they charge me less than, or if they charge me more than $26 for that watch, I know that they did something wrong, right? So be a smart consumer. All right, then look at the next section down below. In this section, you have to state whether each percent of change is a percent of increase or a percent of decrease, and then find that percent of change. So we're going to use a proportion for this. All right, and so these ones are the most difficult section on your homework. So here's our proportion. We are finding percent of change. Okay, so the minute you see that word percent of change, I want you to think of the following proportion. So we've got, where do I want to put it? Let's put it over here. So I have a percent is based on what number? 100. So you have a percent of item is based on 100. You're going to have to find the change in amount. Have you seen that triangle before? In physics, right? Doesn't it usually mean change? So your change in amount, which means your original minus your new, or it could be your new minus original. It depends on which one is bigger. You're going to divide that by your original amount. You can do this a couple of different ways. So this is one way, and those of you who are highly algebraic minded will like this way. Then there's another way for those of you who will struggle with this. And there's the only time that it will, well, you're going to have both your original and your new. I'm not going to give you one without the other. So this should work okay. All right, so let's look at number 9. So number 9, you go from an original number to a new number of 25 to 10. Did you go up or down? So that is a decrease, right? We went down. So that is going to be a percent decrease. That's one of the things that they're looking for. State whether it's a percent increase or a percent decrease. So that's one thing. So we've answered that question. Now we have to find the actual percent of change. So in your formula, there's one thing that's always there. Your 100 goes there. You're not going to know your percent. Isn't that what we're finding? So that percent, let it be X. That's your unknown. So we're going to set up a problem like you had yesterday. Then we have to figure out our difference between our original and our new. So for your note purposes, I need you to actually physically write out 20, whichever one is bigger, 25 minus 10. If the new is bigger, then you put that first. You want that to be a positive number because we've already determined it's a decrease. What's your original number? 25. So then that goes down there. So really, I have a proportion that is X over 100 equals, what's 25 minus 10? 15 over 25. So you could either do your cross products now, or can't you reduce this 15 over 25? What goes into both 15 and 25? 5. So 5 goes into 15 3 times, and 5 goes into 25 5 times. We could do that as well. So we'll talk about that also. So then you can do your cross products of X times 5 is 5X, right? Equals, what's 100 times 3? 300. And then to solve, divide both sides by 5. And you get X is equal to 5 goes into 30 6 times, 5 goes into 0 0 times. So your percent of decrease is 60%. And you have to put a percent sign on the end of that answer because X represents a percent. So then Stephanie brought up a point. If I'm looking at this percent right here, remember if I can do something to 25 to get to 100, can I do the same thing to my top number to get to X? In this case, what do you multiply 25 by to get to 100? 4. What is 4 times 15? What's 4 times 15? 60. So couldn't you have gotten the answer that way also? Yes, not all of these problems will work out that way, but yes, you absolutely could do it that way. All right, so then look at number 14. So this time I go from 200 to 320. Is that an increase or a decrease? So this is an increase, so I have a percent increase. So set up that same proportion. And then I'm trying to find my percent, so it's x over 100 equals what over what. So to find your change in amount, this time the new is bigger, right? Whichever one is bigger, put it first. But what's my original amount? The 200. So I've got x over 100 equals, what's 320 minus 200? 120 over 200. So this time, I could divide 200 by what to get to 100? 2. So what's 120 divided by 2? My answer should be 60, right? Or I can just reduce. I can reduce vertically. I can take away each of those zeros, right? And then I could reduce each of these by 4. 4 goes into 12 3 times. 4 goes into 20 5 times. And I can do my cross products. X times 5 is 5x equals 3 times 100 is 300. And isn't that same problem that we had earlier? Divide by 5, and sure enough, x is equal to 60, and don't forget to add the percent. All right, you try number 16 on your own, even though it has decimals, right? Even though it has decimals, you're allowed to use a calculator. So if you have your calculator handy, go ahead and use it. Otherwise, it's not that too tough of a decimal. So decide if you have an increase or a decrease. Find your change in amount. Put in your proportion. Cross multiply to solve. Yes.
I confused when I got to 3 and 5 and I didn't do it.
Here?
Yeah, 14.
So I canceled out the zeros, right? So I was looking at 12 and 20, 200, 12 and 20.
Okay.
What's the biggest number that divides into 12 and 20? So I
Six.
divided them both by 4. So 12 divided by 4 is 3. And 20 divided by 4 is 5. And that's kind of the same thing I did over here. 15 and 25, they have a 5 in common. So I divided 15 by 5 and got 3.
I thought you were taking 100 and I was like, this is 10.
Yeah, no. Does that make sense now?
Yeah.
Okay. So here's an example of where, I don't know what I did to 58.8 to get 100. So you have to know to use cross products. So I'm going to multiply the x to the 58.8 and the 100 to the 6.9. And so I get 58.8x equals, when I multiply anything by 100, doesn't that move the decimal 2 places to the right? So I don't even need to break out the calculator. I get 690. Then to solve, divide by 58.8 to both sides. Calculator comes in handy, right? X is equal to if you're not told, then you can round to do decimal places. But what did they say to round to? To the nearest whole percent. So the whole percent is right here at the 1. What number follows that? A 7. So it gets bumped up to a 12. right? So this becomes 12%. Does that make sense? All right, so flip it over to the back. We have a couple of conversions that we were doing yesterday, right? So here would be my suggestion. You have to write the ratio in simplest form. So this is your mixed review. I just want to remind you that you need to start with 8 days over 4 weeks. And if you watch my video for 7-1, kind of towards the middle of the video, I talk about how to find conversion units. For instance, I put Gallon Man on there. It has all the conversions for quarts, pints, cups, how many ounces are in a cup, how many ounces are in a pound. And then I talk about how to convert decimals, grams, liters, and meters into their equivalent decimal forms. Remember, King Henry died. Did your teacher teach you this? Drinking chocolate milk. But then there was some conversation in my 6th period class about meters, liters, and grams. So King Henry died Monday, looking good. That was different. Drinking chocolate milk. So it got Monday, looking good, is your meters, liters, and grams. Because if you just do King Henry died drinking chocolate milk, you're going to miss your units of your 1 unit of measure, 1 meter, 1 liter, 1 gram. So I go through a whole explanation on there about that, so you might want to watch that. But here, what's your conversion for days and weeks? How many days in a week? So does days go up top or on the bottom? Yeah, because I want the days to cancel, so I want them to be diagonal, so 7 days to 1 week, right? So that means that the weeks cancel and the days cancel. The 7 doesn't cancel with the 8 or the 1, but the 4 cancels with the 8, doesn't it? How many times? Twice. So then multiply what's left over. So 2 times 1 is 2 over 1 times 1 is 1. So it is a ratio, right? So we're going to leave it as 2 to 1. So then you'll have to do the other 2 on your own. And then they've got some more proportions in there, but let's talk about number 24. Absolute value of x is equal to 5. What does absolute value mean again? Because this was from way back when. Cameron? The distance from 0. How far is 5 from 0? 5. Is that the only number that's 5 units from 0? What other number? Negative 5. So remember, absolute value, that has 2 answers to it. Because x can be a positive or a negative 5, but then when you take the absolute value of it, it becomes positive 5. All right, then let's look at 26 for our final problem. So I'm going to pan out here a little bit. So here's how you're going to do 26 and 27. You've got, in the school, there are 4 Boy Scouts to every 3 Girl Scouts. If there are 42 Girl Scouts, how many Boy Scouts are there? If there are 81 Girl Scouts, how many Boy Scouts are there? So it's a word problem, correct? Which one do you don't know? Number of Boy Scouts. So I'm going to let x equal number of Boy Scouts. And they're actually setting up the ratio in the proportion. Remember, proportion are 2 equal ratios. So they talk about the ratio. There are 4 Boy Scouts to every 3 Girl Scouts. Isn't this your ratio? 4 Boy Scouts to 3 Girl Scouts, right? So that's telling you that we want Boy Scouts up top and Girl Scouts on the bottom. And it says if there are 42 Girl Scouts, wouldn't that go on the bottom? How many Boy Scouts are there? There's my x, right? Can I set those equal to each other? I've got boys to girls. Boys to girls. So ignore the Boy Scouts and the Girl Scouts. Just look at the numbers. I cannot cross cancel across an equal sign, but I can solve by doing cross products, right? So I get 3 times x is 3x, 4 times 42, what's that? 168. And then how do you solve? Divide by 3. Can you have a partial Boy Scout? No, so if you get a decimal, probably something's wrong. 3 goes into 16, how many times? 5 times, that's 15, right? Doesn't that give you 1 left over? So 3 goes into 18 6 times, so she's correct. 56 Boy Scouts, right? Then the question says, if there are 81 Girl Scouts, how many Boy Scouts are there? So this is the answer to the first part. So therefore, there are 56 Boy Scouts. So they're asking us a second question, aren't they? So this is question number 1. Here's question number 2. Now you set up a proportion. I would use the same 4:3. You set up a proportion if there are 81 Girl Scouts. You figure it out. When you get an answer, share it with those around you. Share it. Talk amongst yourselves. So what'd you get? Surely you have the answer by now, right? What'd you get? Did you get 56? No. 108? Does anybody disagree with that? Good, because it is 108. So you should have set up 4:3 as x is to 81. That's how your proportions are read. I cross multiplied, I got 3x equals 324. You divide by 3, you do get 108. So 27 is very similar, so you want to figure out what's your ratio. You've got a robin flying, and it's beating its wings so many times per so many seconds, right? So your ratio should be either, beating per second or second per beating. It doesn't matter which. So I'll let you finish this on your own.